Hey guys, Buildzoid here, and today we're going to be well, not taking a look. I'm going to be sharing some of my thoughts on the Vega Frontier Edition card. So, and sort of more overclocky stuff I've been doing. I've also experimented with undervolting, a little bit with overvolting. Obviously, I've swapped the cooler, um, and I've done a bit of modding on the back of the card as well. So, warranty is now bye-bye. So I guess I really should thank all the Patreons for making this entire thing possible, because none of this was there's no sponsorship behind any of this card. Um, so huge thanks to the patrons for making this video, like all of the Vega Frontier Edition content possible, really. So yeah, let's take a look at it. So first things first is the cooling setup. So I have two Corsair ML series 120mm fans. These are the ones that go up to 2.4k RPM. And honestly, I think Corsair is onto something with that maglev bearing thing, because these are very, very quiet for almost 2,500 RPM. Which really surprised me because I use a lot of other high RPM fans, and these are by far, I think, the quietest ones I've dealt with. Now, I'm not sure how much air they push or how good at cooling they are, but at the very least, they're quiet. However, knowing, just for freestanding airflow, these definitely don't push the most air. I think the fan that I've tested that pushes by far the most air in a freestanding environment is the Cooler Master. What are they? The jet flows, which they've now renamed to like the Master Maker thingy majiggies. Anyway, those push more air at like 2,000 RPM, but those aren't radiator fans. You stick them on a radiator and they're pretty much dead. So obviously on a relatively high fin density heatsink like the Morpheus 2 from Tech here, that would not work, like at all. And that's why I've gone with the ML series, because they're actually doing a pretty decent job of actually cooling the core. What they're not doing a good job of is cooling the VRM. Mostly because this fin stack just slows down the airflow so much that by the time it hits the VRM, it just doesn't really do anything. Um, so yeah, I do have a cooling issue on the card right now. And even the freaking heatsink, the Morpheus 2, it's six 6mm heat pipes making it up. I'm 99% sure I've managed to saturate this heatsink on more than one occasion. And what I mean by that is heat pipes have a sort of upper mass, like they have a maximum wattage throughput. If you hit that, they kind of stop working. They can't really transfer much more heat than, say, 30 watts using the phase change effect that they function on. That stops working past a certain heat load. And I'm pretty sure that this card right here manages to do that, because I've had it pulling as much as 460 watts through the two 8 pins, and those two 8 pins provide all of the core power. So the core was probably putting out, maybe after VRM losses, which is a good chunk, the VRM losses on this thing. I think the losses are around sort of 40 watts, maybe 50, in that sort of area at the current draws that I've been hitting with when I had the card at 460 watts power consumption, it was running about 50, 40 watts of VRM heat. And at that point, you're looking at still like 400, 420 watts of heat output on the GPU core itself. And this heatsink kind of can't deal with that, as far as I can tell. Now, I haven't had the temperatures go super high yet, but the main reason for that is I've not run the heatsink, like I've not saturated, like I've not steady stated the card. I've not run a long-term stress test on the card because, as I said, I have a major VRM cooling issue, and the VRM is throwing off about 40 watts, 40, 50 watts of heat at this point. And if I actually try to steady state the card at that, like at maxed out power consumption, it's going to overheat the VRM. And I don't know about you, but I like having my VRM on my 1,000 quid card functional. Um, because if it wasn't, I'd have a really bad day. Especially considering the layout, it's just like e-powering this thing is going. If I ever had to e-power this, this would be a nightmare. So I'd rather not do that, and so I'm very sort of being kind of careful with making sure that I don't blow up the VRM. The main reason for the whole VRM thermals for me issues is there's just not enough airflow. I'm hoping to solve that with some kind of cooling plate sometime in the future, which a friend of mine has offered to sort of help with manufacturing that. So that'll be pretty cool once I throw that on there. Core temperatures, I've not seen much in excess of, I think, 55 degrees centigrade, but that already is pretty high for a heatsink this big, and especially considering that that wasn't continuous load. That was just however long time SPI takes to finish. So, yeah, it does run pretty damn hot, and I'm kind of worried about what on earth the AIBs will have to do to make RX Vega cooler, unless AMD is going to release like a new die for the GPU or something that is way more efficient, which I don't think they can just spin up a new die in a month. So I really doubt that's going to be happening, but yeah, right now this thing is really, really power hungry and it needs a really big cooler. So that's a bit of an issue. But yeah, the main reason is like I could throw the card on an AIO, and I had the card on an AIO for a little bit, and the AIO was definitely better than this air cooler. The thing is while I was doing all of my modifications on the card, it's just way more convenient if I can pull the card out of the system and just do all of my mods on the back, which that's partially down to the PCB design. We have the voltage controller right here. All of the circuitry I really care about is on the back. So I don't need to deal with the front side of the card basically at all. And that means, you know, having the air cooler is really, really convenient. If I was working on something where the voltage controller is on the front, then I'd actually rather have the AIO, because then I don't have to unmount, like, I could get to the voltage controller while the AIO is still mounted. But this card has the voltage controller on the back, and AIO is just like making space for, like, moving radiators around and all that is just a pain. So this is more convenient for me while I'm working with the card, like, quickly. Ultimately, I think for proper testing, yeah, it needs water cooling because it just runs so hot. And also, once I switch it to the AIO, I can point a, you know, high airflow fan directly at the VRM, and I don't have a cooling issue any longer. Because the VRM does have a good amount of surface area on its own. It's just kind of starved for air, and the little air that it gets right now is also preheated by the by the GPU heatsink. So that's not great. So that's sort of the that's sort of the cooling situation. How important is cooling on Vega? Well, this thing is ridiculously temperature sensitive. So HBM benefits from running cooler. My card on the stock air cooler will not do 1100 megahertz HBM at all. It's just like it might not, it doesn't even reliably do 1050. Gamers Nexus seem to have they seem to have a Vega that just runs circles around mine. Mine, even on the AIO, I maxed out at like 1680 megahertz. So mine is really not a spectacular sample. And yeah, it needs the extra cooling. Like, it really, really needs it. So that's a bit of an issue. So my card's super, like, it needs a lot of cooling. Yeah. That's a thing. Now, if you actually look at, say, let's start talking undervolting, just because I can't figure out how to transition topics right now. I have undervolted the card. I've got it all the way down to 1100 millivolts for 1600 megahertz. I did not stress test fully, like, I did not do a stress test at those settings. It just sort of ran time SPI and it worked and it scored fine. I've been, ever since I dealt with that whole thing where I can get a 1070 to show 2.1 gigahertz and score like it's running 1500. I've, you know, done performance checks every step of the way with everything. Also because I'm keeping an eye on the, you know, maybe the Fury X issue of, oh, you added extra voltage here, your FPS goes down to hell. I'm also keeping an eye out for that. So I've been very, very specific about just keeping track of scores all the time. And yet, undervolted, 1600 megahertz, 1100 millivolts. This card runs just fine. Power consumption goes way down, like absolutely way down. I think it's down to AMD's binning process for GPUs just being the loosest thing on earth. I mean, if you look at like RX 480 card to card variants, it's awful. Like, it's just awful. Like, you can get some absolute rocks of RX 480s. You can get cards that won't do 1400. Even with a ton of extra voltage, they'll, like, be borderline on doing 1400. And then you can get cards like, say, my GTR, which does, like, 1500 megahertz. So, yeah, AMD's bidding process for GPU is very, very loose. They basically take anything that runs, and the side effect is extremely high voltages. So a lot of cards end up with extremely high power draw out of the box. So, you know, if you don't have the biggest power supply on Earth and you are interested in running a Vega, yeah, you can totally undervolt. And in fact, you can undervolt a bit and you can overclock at the same time. My card, due to the whole temperature thing, if you undervolt and you have a nice cooler, you can actually still run the same kind of clocks you could do on like the stock air cooler. So that's pretty cool, I guess. I'm really not sure because, you know, I know we're gonna be seeing like a reference RX Vega at launch probably, and I'm kind of terrified because if it gets that blower cooler again, then well, be prepared to at least switch to an AIO or something if you want any kind of that like decent experience because that stock blower just sucks very badly. Okay, so yeah, and it's not a case of it's a bad cooler. This card just runs too hot. That cooler could, like, if that cooler was on, like, a 290X, I think it would be doing an excellent job. This isn't a 290X, though. This is a lot worse. Um, but yeah, it does need to run cool to overclock well. Um, Voltage scaling right now, I haven't really tested voltage scaling much because I do have that VRM cooling issue, and if I crank up the voltage, the VRM is just going to absolutely hate me for it. Potentially commit suicide, and then I'll hate myself for driving a VRM to commit suicide. You know, that's a very sad thing to do. Um, but yeah, it's like, so I haven't tested high voltage. I've had it up to 1.23 volts. It kind of helped with stability, but quite frankly, it didn't help that much because the temperatures just shot way up again. So, you know, you can get better overclocks at sort of lower voltage more so than at high voltage because high voltage brings the higher temperatures and the card really doesn't like those. Um, if this was on an AIO, more voltage I'm certain would help. If this was on liquid nitrogen, I'm sure it would probably scale, you know, depending on how far this can go on liquid nitrogen in low, how low you can push this on liquid nitrogen in terms of temperature, this could probably scale up to 1.5 volts. At which point it's going to probably suck around 800 watts alone, which you might be thinking, that's a lot of power. Actually, no. By liquid nitrogen cooling standards, that's not a lot of power. A lot of power on liquid nitrogen, well, actually, no. It is a lot of power, but it's not the most. The most power ever pulled by a GPU, as far as I know, is 980 Ti's and 780 Ti's. Those things could hit a kilowatt average power consumption on liquid nitrogen. So this right here, if it was doing 100 watts, would be relatively okay. But it is very, very power hungry. And with liquid nitrogen, like, you could crank up that power consumption higher, but I've not tested, obviously, because I have one card. And the other issue is I'm really expecting a big major performance gain when we get some new drivers for Vega. Because right now, the performance just isn't there. It's just, like, this is literally slower than a Fury X, clock for clock. So there's stuff obviously that AMD still needs to patch up or something, and even like the RX 480, which I think launched in a relatively okay state. 2 months into, like, 2 months after launch, it got a driver that picked up 10% performance for free. So, you know, it's like this is the first big change we've seen to GCN in ages, really. Like, this is still GCN at its core, but it's like very heavily modified GCN. You can still more or less run it. Like, AMD's managed to get this card to run on modified Fiji drivers by their own admission. That's what they were running at all the various demos. But so it is still very GCN based, but it's a big, big update. It's like a bigger update than we've ever seen before, and so naturally I think there's more work to be done on the drivers, especially because it looks like they've really, really rushed to get the Frontier Edition out. I mean, the Frontier Edition name, I mean, it already tells you, Frontier, early. It's pretty much early access. So I'm not going to run liquid nitrogen until we see some major improvements in driver performance, just because if there's a driver that comes out after I run my liquid nitrogen session and it boosts performance by 10%. Well, I've just wasted a lot of liquid nitrogen, haven't I? So that's the logic behind that. And now let's talk modifications I have on the card. This card is cool because it's the first AMD card I've managed to power mod without making it look like really bad. This looks pretty bad, but this is not the worst I've ever done. The worst I've ever done is my 290X. That thing looks like it has a tree, like a bush growing out of where the voltage controller is, because I'm not hand soldering 201s. I'm sorry. They're 2 millimeters by 1 millimeter. Like, I can barely freaking see the damn things. I'm not soldering those by hand. So I ended up running extension wires for everything, and basically there's just like this horrible nest of extension wires right over the voltage controller on that card. Luckily on this card you don't have to do that, because AMD went ahead and positioned all their current sensing circuits in very convenient places. So let's take a look at that. So as you can see, I have 6 focus, damn it. Focus. There we go. It's like a distracted middle schooler. It's made of sharp angles. How can it not focus on this? Seriously, it's like all these focus technologies are supposed to be like edge detect. I've never seen anything more edgy than a PCB. So freaking focus, damn it. Come on. Okay, you know what, potato? We're going to do this by hand. I'm going to deal with you manually. Where's the mouse? There's the mouse. There we go. I got it kind of in focus. So these resistors going around the card are actually, these are 2.7 k ohm, so 2,700 ohms, and they're in parallel with the current sense circuits. So as you can sort of see right there, and I'm going to get the autofocus, well, I'm going to focus it even further. There we go. That's nice, isn't it? So you can see that resistor is going from a capacitor and then to another resistor. And basically, normally the resistance across that capacitor is 550 ohms. And that capacitor above it is in parallel with that capacitor below it. At least according to my digital multimeter. I'd really like to take an oscilloscope to both of them to check that the voltages on both of them are exactly the same. But I do not have a multi-channel oscilloscope right now, so I can't do that. But basically that capacitor is used to measure the voltage drop. There we go, back in focus. Well, it's not so much used to measure the voltage drop. It's basically used to measure the current going through through the inductor of a phase. And that's why we have 2 circuits, because there's 2 inductor. Like the voltage controller sees this right here. That's the 35217. That sees 6 phases. It can't do more than 6 phases. So this 12-phase VRM needs 12 current sensing circuits that then somehow get combined into something the 35217 can actually read, which is 6. So the end result is that the current sense circuits are essentially in parallel with each other. So for every 2 phases, you get 2 current sense circuits that are basically mirrored on each other, like we have here. And so if you add one resistor to either of the 2 circuits, so, you know, I've put it on the lower one here, it actually skews both of them at the same time, at least in theory. If I had an oscilloscope, I'd really love, like a better oscilloscope, I'd really love to check that both of those capacitors are running the same voltages under load. Because if they're not, then what I've ended up doing is accidentally skewing the VRM towards loading one phase more than the other, and that causes issues. At least in theory, because, again, this can't see multiple phases. So, well, this can't see 12 phases, it sees 6. So I think regardless of how I skew this, it should still not care, but I just have, you know, ever so slightly doubt myself about that, because it just doesn't seem right. And I do know for a fact that the IR3598 right here can't actually do it, like, that doesn't interact with this circuit at all, the current sense circuit. So yeah, but basically that's how you mod it, because that 2,700 kilo ohm resistor drops the resistance across that capacitor from 550 ohms down to 450 ohms. So it basically drops by 100 ohms because we've put an extra resistor in parallel. The end result of that drop in resistance is a roughly 20, well, it's a roughly basically your resistance goes to 0.81 of its original, and you basically get roughly 20% more power limit. So that's really cool. The end result is now the card tops out at 460 watts of 8-pin power draw instead of 375 watts of 8-pin power draw. Essentially meaning, yeah, the power limit is up by 20%. End result is my maximum power limit on the card currently is plus 80% because it stacks with the software power limit of plus 50%. So you do plus 50% and then plus 20%, so that it's not 170, it's 1.5 times 1.2, because this applies, they're multipliers, so they apply on top of each other. They multiply each other. So that stacks. Then here you can see these polymer capacitors right here. And these are very expensive, very, very high-end SMD polymers that I added. These are from Panasonic. And they do absolutely nothing. So AMD's done an excellent job of making sure that the low frequency component of the power rails is really, really well filtered. Like there's no amount of polymers you can add to this VRM that will make it perform any better. Maybe adding some more multi-layer ceramics right behind the core could help. Maybe attaching some tantalum capacitors right behind the core could help, since both of those types of capacitors have much higher frequency ranges than polymers. Polymers are really only good for a couple hundred kilohertz at most. And, well, I've just said the low frequency component is taken care of by what AMD's already put in terms of capacitance on the card. So the stock VRM is actually really, really nice. Now then, this right here is obviously for voltage sensing. I've soldered to that capacitor specifically because if you measure off of like these right here, these read higher voltage than that. This one has the most droop of any, well, most voltage drop of any of the capacitors behind the core. These guys will read like 1.2 because they're right on the output of the VRM. In fact, if you look at the front of the card, the chokes are basically where the capacitors have their positive pad. That's where the chokes would be attached. So you get like, you basically read 1.2 volts right there, stock voltage being 1.2 volts. Right behind the core, you can see my resistor for the hookup. That then goes over there, and I can read that with a multimeter. So that's for vCore. You can also mod the voltage control of the IR35217 physically through one of the circuits we're looking at. Well, I think I need a pointer. Damn it, I need something to point with. Here. Actually, that's still not small enough. There. Multimeter probe. So, well, okay, I'm actually not going to be able to show you. I can't multitask that much. But that is modifiable. I figured out how to mod that even without a datasheet, so I've posted a photo on Facebook of that if you're interested, so you can just look that up. But yeah, so I've managed to power mod the card. I've managed to volt mod the card. Speaking of voltages, you can actually get voltage control on this through Watt Tool in Windows. Watt Tool works. You just have to be careful to not... I don't know what actually triggers it, but if you adjust something in Watt Tool, your HBM will underclock to 500 megahertz, and then you have to restart the computer to fix that. That's the only way to get rid of it. You might be able to refresh the drive. Maybe if you refresh the graphics stack or something, it might go away, but I'm pretty sure you have to restart to fix the HBM underclock that happens if you screw with some setting in Watt Tool. If you just adjust voltages, you're fine, but if you try playing with the frequencies, it gets kind of weird. I think it happens if you try to adjust the other P states. If you only adjust the main P state, you're fine. If you try to adjust the lower ones, it seems to lock the memory to 500 megahertz. So that's kind of annoying. But you can control voltage. I am not sure where there's an upper limit in terms of voltage. I'm 99% sure that since it is using the sort of... it's not using offset voltage. I'm 99% sure that if you go through Watt Tool at some voltage level, it will trigger a safety, in which case you'll have to resort to the physical modification to get any more voltage than that. But really, I think that's only, the physical mod really only applies to people who want to run liquid nitrogen or dry ice or something like that. For regular usage, I think it's completely pointless. So, yeah, I think I've more or less rambled on about everything I wanted to ramble on about. If you've got any questions, comments, or whatever, you can leave them down in the comments, right? You can share, you can like the video, you can share the video so that more people get, well, more people watch it. That's the freaking point, isn't it? Um, it's kind of late at night, and I've been awake for a long time. So sorry about being even more disjointed than usual in my speech. Um, like, share. Oh yeah, if you haven't subscribed already, you really, really should. I mean, you made it to the end of this video. You'd probably make it to the end of all the other ones I put out. Um, and you can support Actually Hardcore Overclocking through a link down in the description below, which leads to the Patreon, as well as PayPal, as well as shirts. Also, if you would actually like to send in hardware for me to abuse, like so, then I do actually have a P.O. box set up. You can message me at buildzoid@gmail.com, and we can talk details about sending things there. And also, one last thing, as far as the supporting AHOC goes, the AHOC Junkyard is a thing. You can go buy used hardware from projects for Actually Hardcore Overclocking. And really, I want to get rid of this stuff. So just make an offer, any offer. Actually, I think I've listed prices at this point. So just go check that out if you're interested in supporting what I do here. And that's it for this video. Thank you for watching, and see you next time.